Good afternoon, everyone. I would like to welcome all the attendees of this session. It's now time to introduce the speaker of the day, Dr. Ilaya Perumal Anamalai. He is working as an assistant professor in the Department of Aerospace Engineering, Lovely Professional University. He has received his PhD degree from Anna University, Chennai, Tamil Nadu in 2021. He has 13 years of experience in both research and teaching. His research area includes aerospace engineering structures, aerospace composites materials, aerospace vehicle design. He is also a member of different reputed organizations like Indian Society of Technical Education and Institute of Engineering. He has won National Fellowship Award from Central Government of India in the year of 2016. He received the Best Research Paper Appreciation certificate from IIT Kanpur, India. He presented his research paper in many conferences. He has 8 research publications, out of which 3 high quality impact factor SCI journals. He has published one aerospace domain book title, Underline of Aerospace Engineering. Now, I would also welcome Rishabh Sharma. He is an officer and area coordinator in Department of Tie-Up, North 1 in Division of Admissions, Lovely Professional University. Now, I would like to hand over things to Dr. Ilaya, and it will be an absolute delight to listen to him. Over to you, sir.
Yes, ma'am. Thank you for your nice introduction. Good afternoon, everyone. Today, very happy day. We are going to discuss some interesting topic about this advances in aerospace engineering. We know, day before yesterday, we have received on good message from our Indian Space Organization that Gaganyaan mission is ready to launch in a short while. So we can start discussing one by one. Like at the end, we will be getting the fruitful results, which is right now what is the current scenario is going and what is the advancements in aerospace engineering. We can discuss one by one. So my screen is visible, right, ma'am?
Yes, sir. I think it is visible to everyone. It is visible, sir.
Yes. So before starting into this advancements of the aerospace engineering, we must know what is aerospace engineering and as well as what is aeronautical engineering. So if you know the definition between the difference between these two, then the advancements when we are discussing, you will get a clarity about what is the difference between these two segments, right? So let me share one more PPT. Ma'am, my screen is visible?
Yes, sir. It is visible.
Can you see this general outline PPT, ma'am?
Yes, sir.
Yes. So before diving into these advancements, so we need to discuss a little bit about the fundamentals of this aerospace and as well as aeronautical engineering, so that it will help us to move forward. So the main difference between this aeronautical and as well as aerospace engineering, just to have a look at it, let me show one simple image. Just to have a look at it, aeronautical, which means whatever the vehicle which will be flying within the sensible atmosphere, that is comes under aeronautical engineering. The people who is interested to take their study in their particularly atmospheric vehicles, then they have to go for this aeronautical engineering. Then aerospace engineering, the beauty part is you will be taking both aircraft and as well as spacecraft. That is the beauty part of this aerospace engineering. So, and moreover, who is really enthusiastic to work with this space and as well as space exploration, they have to dive into this aerospace engineering for their passion towards that. They will be end up with the final destination. So this is the basic difference between this aeronautical and as well as aerospace engineering. Then have a look at it. Main difference between this and this will be very simple, and we need to know after finalizing, we need to know where the space exact starts. So if you know this, then fundamentally you will know everything. Like the space, we can call it as outer space, which will be starts exactly 62 miles, and as well as in kilometers, 100 kilometers above the Earth surface, we have one line. That line called what? Thermal line, from where the space starts. So, what is the main difference between why we are calling it as space? There is a line, Karman line. So, below the line, we can call it as the air molecules, which we can have that air breathing engine and all, we can use it within that sensible atmosphere. But when you are going beyond that Karman line, so we cannot get the air molecules that much in order to use the air breathing engine and all. That's what we will be calling it as space vehicle, which will be comes above the Karman line, that we can call it as space vehicle. Then within the sensible atmospheric vehicle, we can call it as the atmospheric vehicle. So the vehicle which is studying in the aeronautical, then above space, that space vehicle we will be studying in the aerospace domain. That is the main thing we need to understand. Then we need to know when we are speaking about the aeronautical. So the first and foremost thing, we need to know how the birds are flying. What is the fundamental behind it, and then how the Wright brothers and as well as all the philosophies came. We need to get the information from the nature, like our birds and all. Like, let me play a small video just to have a look at it. You will get a better understanding how our pioneers they have developed all the theories based on the nature. Let me open the link. Can you visualize this? Can you visualize this video clip? Like, there is a wing in the bird. Like, the bird, whenever the bird which is flying in the air, there will be a high pressure which will be acting under the wings of the bird, so that the bird will be lifted up and then the bird will be can fly. So we have adopted all the scientific things from the nature. Nothing we have discovered from like artificial. So we have captured all the scientific things from the our nature.
Sir, sorry to interrupt, but your video is not coming.
One minute.
Sir, please share the screen again with that video.
Sir, can you see me now, sir?
Sir, we can see your presentation. All you need to do is click on stop sharing and then click again on share screen.
Yes, sir. Yes.
Now select that video, sir.
Let me go with this entire screen, sir. That will be
right, sir. Right.
Sir, now can you see, sir?
Yes, sir. Now it is visible.
So let me repeat this point.
Looks like an upside down.
Yes. So actually, the lift, how the lift is generated in our aircraft, the main and the fundamental principle is, under the wings of our aircraft, we will be having high pressure, and as well as on the top of the wing, we will be having less pressure. This is the theorem, we can call it as Bernoulli's principle. So this is the fundamental principle behind this, our atmospheric vehicle, how the lift is generated. So we have adopted all the basic things like scientific things from our nature only. So let me come back to this presentation. And the next one is what is the shape we need to get the things to fly. So this is the shape, we can call it as airfoil shape. So it is perfectly suitable to take the air without taking much drag. Drag is nothing but it is a kind of resistive force which will be like resisting the motion, that motion of the body. So this is the shape which we have described, which we have found to in order to take the aircraft in the air. So this will be the one which will help us to take the all vehicles in the air. So this is the airfoil. Each and every aircraft components, you can take it out. The airframe structural member will be look like this. The shape will be leading edge will be there, then followed by trailing edge will be. So there will be four forces will be acting in an airfoil like lift, drag, and as well as thrust weight. Let me quickly outline. So this is the wing. Whenever you want to design your own aircraft or own wing, we need to analyze the wing with respect to what with respect to the air. We have to analyze how much drag which is producing, how the flow is, everything we need to understand so that it will be capable to produce the lift or not. We have to simulate before taking the model into the final thing. So this is the airfoil data like how there are three classifications of there. So positive cambered, negative cambered, and then symmetrical airfoil. So we will be using most of the time positive cambered airfoil. Why we are calling it as positive cambered? So whenever there is a angle of attack 0, you will be getting a positive lift. That's what we are using this angle positive cambered airfoil. So this is all about the atmospheric vehicle fundamentals. Now, general outline about this atmospheric vehicle. So we need to know what is the main difference between aircraft, airplane, and as well as your aeroplane. So aircraft is nothing but it is a machine which will help us to transport the passenger and as well as cargo from one place to another place. Then what is the main difference between this aircraft, airplane, and aeroplane? Aircraft, which will be referred like whichever which is flying that aircraft. Airplane and aeroplane both are will be same, but when you are speaking about aeroplane, which will be in the British spelling, that is the main difference. Then these are all the fundamental parts and functions of your airplane. And when you are coming about the forces, there are four forces that we discussed: thrust, drag, lift, and as well as weight. Then what are all the shapes which is going to affect the drag? Drag is nothing but the resistive force which will be dragging the aircraft. And we know why. What is the reason we are using the cylindrical shape in our fuselage? So this is the beautiful area where people are working in the last uh, past decades and all during our right brothers time and all. Like in order to, there are two reasons behind this. One is in order to minimize the drag, and second one is there is a concept called what stress concentration level. So the stress concentration level will be uniform throughout the cylindrical shape. That's what we are using this fuselage section in the cylindrical, or otherwise we can use this square or rectangular shape. When we are using this shape, right, stress concentration level will be uniformly distributed throughout the all along the length of your fuselage. So that is the beauty of this cylindrical. If you are using square shape or rectangular shape, your stress concentration level will be very high in the corners. So your structure will be collapse over the period of time, within short period of time. Then your structure will collapse because of the stress concentration level will be more at the corners. So that is the reason. So people will be started doing this many research to modify the materials of the fuselage, and then they are still doing some research to develop the new materials for this fuselage. So as we know, Newton's three laws we know. Then let me go ahead. There are three rotations are there in our aircraft: the pitch, roll, and the yaw. Roll, yaw, and the pitch motion, like you know. Then when we are speaking about the space vehicle, where we are most of the time like aerospace engineer will be like they will be enthusiastic to work in this space vehicle. The main difference we will be like taking the space vehicle into account. So in order to discuss about the space vehicle, you need to understand both atmospheric and as well as space. So in sensible atmosphere, you need to take all the aerodynamic phenomena into account, and as well as in vacuum, in space, you need to take account of the space environment, like what will be the radiation, what will be the sun influence, and what will be the other planets influence. If you are speaking about interplanetary trajectory, you have to discuss everything about that, so that it will be easy to track the trajectory of your mission and all. So we can discuss a few things about the space vehicle. So this what is atmospheric vehicle? So whatever which is within this atmosphere, we can call it as atmospheric vehicle. What is space vehicle? Space vehicle which is beyond the atmosphere, that we can call it as space vehicle. Then categories of space vehicle we can divide into three: Earth satellites and as well as lunar, or we can call it as interplanetary interplanetary vehicles. The interplanetary is nothing but we are launching a satellite from Earth to Mars. That is comes under what the interplanetary vehicles. Then lunar is nothing but it is Earth to our moon. If you are sending a satellite, that will be called as lunar mission. Like the best example, we can call it as Chandrayaan 1, 2, 3, and like which is comes under what lunar, like space shuttle, which will help us to keep the things happening. Then the Earth satellite, which will help us to keep the whatever the Earth satellites, we can use it to observe the Earth, and as well as scientific reason and all, we can use it, this Earth satellite. Then lunar, as we know, like we can take our Indian mission, ISRO mission, Chandrayaan 1, 2, 3, and lunar mission. Then this is a simple trajectory, like how we are taking the satellite space vehicle from one planet to another planet. Below we can see this Earth which is there in the shaded. The top you can see this moon, that is also like we are planning to send a satellite from Earth to moon. This is the trajectory profile of our planet. So this is the Apollo mission, which is developed in the 1969, July 20. Then space shuttle, which will be like re-entry will be there. So we will be lift off from the take off from the Earth surface, and then after our mission, we will be coming back to the Earth. Then that is also called as space shuttle. This is a space shuttle. Then this is the sequence of your space mission, like how the basic and as well as profile of your space vehicle. You have to take the atmosphere, then you have to complete the mission, then come back to the same atmosphere after your mission. Then this is a simple payload, and as well as that is with the launch vehicle. This is a small video. Let me play small video.
Seconds. The ground launch sequencer will start bringing a high energy system online. Atmosphere will disappear. See it coming out there now.
So actually, the
There it
launch
goes.
vehicle, which will be
Launch
used to
vehicle.
the payload in the top of your launch vehicle.
15 seconds. That thrust vector control actuator test. Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage.
So there are two things we must understand about this satellite and as well as launch vehicle. So launch vehicle, which will help us to take the satellite into the particular orbit. Then once the satellite is injected into the particular orbit, then like our satellite will be start working, and then it will take the inputs from that orbit, and then it will try to help, try to send the information to the Earth wherever we are focusing. Then that will be targeting, and then that will give the information about the geographical data. Then with that we can able to track the we can track the all geographical location, and as well as we can monitor the agriculture field and everything, navigation purpose, and as well as defense purpose we can use it. So this is a simple thing, and one more thing we need to. And this is the mission in space, how it will be like launched, then followed by ascent, then staging, then separation, then at last we will be injecting into the space, then re-entry. There are different planets which we are interested, but mostly we will be dealing with this Earth and as well as Mars, our interest. So whenever you need to reach other planets, you need to have more propellant. That is the challenging part, as our all space agencies are facing. So these are all some fundamental things. How the orbits are classified. So based on the altitude, based on the position, and based on the inclination, which will be classified. So Leo, Geo, Meo, and all is there. Like there are different orbits are there. Based on the altitude, we can classify. And what will be the thing which is keeping the satellite in the orbit? Like there will be a balance between your gravitational force and as well as centripetal force, which will keep your satellite in the orbit. Until unless you are giving any disturbance to the satellite, it will be uh, keep on revolving in the same orbit. If you are increasing the velocity, then it will leave the current orbit, and then it will enter into the second orbit. That we know. Then what is the ISRO's upcoming mission? We know like our Ganganyaan will be the one which is day before yesterday. We got the information like we have found 4 astronauts. They are like ready to take our space mission like Ganganyaan today. Ganganyaan. So this is the like uh, how the what is the capacity, and as well as what will be the this is the rough idea. This data they have published long back, but now maybe like so. This is the just general thing we need to know before start discussing this about the advancements of the aerospace engineering. Now we can start about this advances of the aerospace engineering. Now have a look at it. So in aerospace engineering, we can take 4 main domains. First, we can take aerodynamics. In aerodynamics, you can do many works. You can do it like you can take any safe structural member, and then you can analyze the flow, and then you can try to bring innovative or novel structure in order to take the aerodynamics. And as well as you can, next domain is the propulsion domain, where we are spending most of the launch vehicle is fully filled with our propulsion, like propellant, fuel and accelerator will be filled with this. The 75% of the space will be occupied by your propulsion system. So there are, that is a second domain we have to discuss more about that. There are a lot of opportunities there in the research. And the aircraft design, that is also comes under a sensible atmospheric vehicle. So here we can do the specific performance like drag, how we can decrease, and how we can increase the jet power, and everything we can do. Then fourth domain is flight mechanics, like which will help us to control the stability of your aircraft, and as well as our aerodynamic phenomena, and as well as the gravitational, everything we have to control with the help of the flight mechanics. Then what is the application of your aerospace engineering? Like whenever you are speaking aerospace, you will be dealing with this both atmospheric and as well as space vehicle. So satellite, we can take it, we can use it for this communication, weather forecasting, and remote sensing, and as well as all other agriculture application we can use it. Then aviation, we can start developing the fighter jet aircrafts and all. We can use it the aerodynamic phenomena, and then we can develop some new technological development towards this fighter jet that we can dedicate to the our nation to save our people who is living in our country. Then space exploration, like as we know, like Chandrayaan 3 is a great mission. Like just now we have completed, then followed by Aditya alone. We know, like we have made a good, we have crossed a good milestone about that space exploration, and still we need to look for this crew-based Ganganyaan. Like we hope it will be like very soon we will get a start of positive response and positive news about the Ganganyaan also. Then, as we discussed, aerospace and aeronautical will be like difference is sensible atmosphere vehicle will be comes under aeronautical. Then, when you are studying both aerospace and as well as aeronautical, then we can call it as aerospace, atmospheric vehicle, and as well as can call it as sensible aerospace engineering. Then what will be the education and how will be the career for your aerospace engineering? So aerodynamics is the domain where people will be dealing the flow analysis of the structural member who is taking the both aerospace and as well as aeronautical. They will be dealing with this aerodynamic. Then followed by they can choose the spacecraft design also, like they can do research and then they can build a they can manufacture new material. They can bring a new research, novel research to the scientific forum. Then they can produce n number of research in the structural domain and as well as aerodynamics also part of that. So both combined together, we can do any type of research. That will be like beautiful. Like whenever you are speaking about satellite, we need to take care of the skin and as well as we need to protect load. So we need to uh, do in-depth research analysis in the spacecraft design and as well as aerodynamics. We have to give it more importance for your aircraft. Like when you are speaking about propulsion, so propulsion where you have to you can define two categories. One is whether you are giving application for the aircraft propulsion that we can call it as air breathing engine. Then second one is non-air breathing engine that we can call it as rocket propulsion. So the two differences we have to come up with this, whether hyperbolic propulsion or we are going with this non-hyperbolic propulsion. So accordingly, we have to do research in the propulsion domain also. So once we complete this aerospace engineering, there are a lot of opportunity is there in our India and as well as foreign countries. Like especially right now, there are many startup companies. They have started to investing in the propulsion domain and as well as structural design domain. Only they are making the specific component and the specific domain. They are focusing and then they are getting funding and all from the government of India. Then they are doing some in-depth research and then they are giving that work to the our space agency also, like our ISRO, DRDO. They are taking input from all startups and then they are doing in-depth research. Then our ultimate challenge for our future, like we need to save our environment and as well as when you are doing in-depth research in the propulsion domain, automatically we have to reduce the carbon dioxide and as well as monoxide and all, which will be like a poison to our environment. So we have to take care of our environment and then in that way you have to do in-depth analysis in order to save our environment and as well as the human beings who is there in our environment. We have to save it everyone. And the space exploration, like we are going to explore the celestial bodies, like how it is behaving. Like there are many number of galaxies that are there. We are in the Milky Way galaxy. Like we need to know, explore that how the celestial bodies are there. Like this is like infinite, like whatever we are knowing about this aerospace engineering. Aerospace engineering will be like little 0.001% we can say. Like there are many things we need to know about that, but people are still doing research in order to find the what is really exactly is there in this space. Like this is the like interesting domain. Like people are really they are dedicated to their life to get the information about the space. And then NASA, we know, well-known agency, they will be keep on updating the information about the space exploration. But we are also ISRO also we are stepping into this, get the information about this space exploration, like the evidence, we can call it as Chandrayaan 3 is the best evidence. So still we will be getting many evidence from our ISRO. And aerospace engineering, the major we can call it as recently, I have added Chandrayaan missions 1, 2, 3 and all. Then International Space Station and NASA and all, they will be like doing research. But when we are speaking about Chandrayaan, on the day of the launch, we have got the notification like Luna 25 also launching on the same day. The main difference between Chandrayaan 3 and as well as this Luna 25, whereas Chandrayaan 3 has will be taking 40 plus days to reach the moon surface, where your Luna 25 will be like taking in a days, it will be like 5 or 6 days it will be taking. The reason behind it, we will be using the half-man transfer trajectory in order to reach the moon surface, but they have used the direct injection method to reach the uh, moon surface. They have spent more money, more propellant in order to take the trajectory, but we have used the method called what half-man transfer. That have we have saved many cages of propellant that directly influencing the money. Like we have spent less amount for the project and then we have done it in a better way. That is the beauty of the ISRO. So we have to be like we have to spend less amount, but in the optimum way, we have to get the perfect output. That we have did that very phenomenal result we got. Then impact in our aerospace, like whatever we are doing, that will be the technological. It should not be affect the environment and the commercial and as well as military aircraft development. We can do it, and then air travel like space exploration, space tourism also is coming. So these are all the some things like, and one more thing, what is the current advancements, like we have getting into this propulsion, electrical propulsion and as well as the materials section, materials domain, we can call it as innovative material, carbon fiber based composites reinforced with this different reinforcements called what nano material like zirconium, ZRB2, and as well as alumina, Al23. So there are many reinforcement people are doing, and then they are finding different material daily. We can find 3 to 4 article, that good article which is coming out from the uh, real researchers. They are trying to give the advanced material to the ISRO and as well as other space agencies also. And we are adopting that also in order to betterment the mission profile and all. And when we are speaking about the material aspect, what is the main advancement? Like we have, we are using composite material. Composite material earlier days, like we have used micro composites. Micro means that reinforcements which will be like in the micro size, but whereas now we have get into this nano size, like the reinforcements which will be taking in the nano size. Then we have what is the main benefit? The surface area will be like we can get better disbursement in the nano size, and that is the beauty of this nano based composites. Then additive manufacturing, under that we can call it as 3D printing and all, like wherever we can we are finding difficult to go to this 3D printing, that will be doing the things in a better way with the lightweight and all. So that is really needed for our aerospace application. So that is the next advancement we have obtained in this domain, additive manufacturing, especially 3D printing is the dominant domain which is propelling our aerospace domain in the another level. It will be like going in the better way. Like then next heat treatment, like whenever you are using this uh, iron based, or like we need to have this heat treatment in order to give the thermal conductivity in order to withstand that and all. We need to ensure that at what level, like there are levels are there T6, like there are levels are there. So we need to ensure that whether it is adapting the temperature or not, we need to check it. So in that way, like all the advanced material which will be meeting, and then we are using the advanced material like in our aerospace structures. Then when we are speaking about aerodynamics and as well as flight mechanics, like we are nowadays using this all like 3D printed structures, and then we are analyzing that with this all computational package called what ANSYS, Fluent and all CF and all we are using, and then based on that we will be taking the stability and as well as control, and whether it is stable or not, we will be checking everything by using the computational method. And then once it is done, then we can admit that into this application. Then everything good, then that will be possible to take the approval for the commercial application. Then propulsion system, like in propulsion system, we need to define into two categories. One is jet engine, that air breathing engine, which we are using for this aircrafts. Then second one is rocket engine. So we are most of the time aerospace engineers will be handling both uh, jet engine, air breathing engine, and as well as our non-air breathing engine, rocket engine. So why we are calling it as jet engine? So we will be getting thrust by using the jet. Jet is nothing but the burned gases which will be comes out from your nozzle. So this both will be like very important domain in our aerospace domain. Like turbine will be the one we need to give more attention, because the turbine will be designed to withstand the particular temperature. So we need to design accordingly. Then we need to choose the suitable material for the turbine also. So the turbine will be the one, and as well as whenever you are speaking about the gases which is coming out through the nozzle, how you are making the nozzle structure and nozzle wall, and what the material it is made up of, what type of cooling system you are providing, everything will be the one we have to give more attention to that. Then electric propulsion nowadays we are using, and the very important point is electric propulsion. We are most of the time we are focusing on it. What the main drawback of our Chandrayaan 3, like we have uh, our Chandrayaan 3 mission only will be like capable to give the information for 14 days of 14 earth days. What will happen after 14 days? We don't have any power to get the information about the lunar. That is the main drawback. But our research team, our R&D team of our ISRO, they have started working on in this energy management. Like they will be working on to develop new energy management that can survive even 1 year, 2 year. But Luna 25 that can survive with minimum 1 year, that can survive. That will take the information from the lunar surface, and then that will give the information to the Russia space agency. That is the beauty. But we are also working on it to get the information about the advancements of this energy management. Then when you are speaking about this space exploration, so spacecraft and as well as satellite, so lunar mission and Martian mission. So wherever you are going, so we need to get the things. We have to divide the things into three. One is material, then propulsion, then second one is the dynamics. So space dynamics and as well as your flight dynamics. So you have to define accordingly. We have to go. So now the future perspective will be like how the challenging and how we are going to eradicate this. So doubtlessly, like we are now going towards this AI integration in all the sectors with what machine learning and all the things which is now coming under this automation, and as well as we will be we will be taking the help of this decision making and then optimization with this AI technology. Everything will be like now under our now the technology is so simple. We are integrating everything with this AI integration. So we will be like saving the time, and we will be getting the uh, optimum input and as well as optimum parameter. We are going to get it to get the final product which will be comes out what we are expecting. But in the older days, we have used the conventional method to get the optimum parameters. But with the AI tools, we can easily find out the optimum parameters and all. That is the beauty of this. So as of now, we are focusing with this next decade, like full and full. This AI will be the one which will be taking all the aerospace domain. Will be the one which will be dominating the entire sector of entire aerospace domain. Then the final conclusion, like what will be the uh, impact in our aerospace, like the aerospace, you have to divide into three. One is propulsion, then second one is aerodynamics, then third one is the flight dynamics. So we need to define where we are going to do, where we are going to modify anything. So modification, which will be like optimum, we will be using the AI tools to get the optimum things. Then after that, we will be taking the sustainability in our aerospace domain. Sustainability in the sense like uh, we should not contaminate any nature and eco-friendly everything like uh, the gases which will be comes out from your nozzle and all that should not spoil the environment, that should not spoil the nature. So you have to keep it all the points in our mind, and then we have to decide which type of propellant we are going, which type of combination fuel and oxidizer we are taking into the consideration before finalizing the things. So and then last point is we are going with this interdisciplinary, like aerospace domain is integrated with this agriculture in order to get the information about this field which is there in our domain. And then drone is the another technology where we are using all the drones for this harvesting, and as well as all our agriculture works we are using that drones and are like fertilizers spraying and all these things. We are now using this drones technology and all, like we are now fully dependent with this AI technology, with this aerospace domain, and with that we can able to produce optimum and as well as reliable and as well as eco-friendly and as well as sustainability goals we can obtain with the AI technology. So this is the outline about the entire things what we have trying to discuss. Like these are all the advancements which is right now which is going in our aerospace domain. So the main domain which we have focused, this focus is this four domains. Aerospace is the combination of aerodynamics, aircraft design, as well as propulsion, and as well as flight mechanics. So we will be like full and full dependent with these four domains only. So our mainstream is main ultimate goal is to develop any technology that should not disturb our ecosystem, that should not disturb our nature, that should not disturb our any surroundings. So this is all about the things we have to keep it in our mind before deciding and before taking any novel research and all in our scientific work. So that's it from my end. So this is what like we need to discuss in a short couple of times. So couple of minutes we have to discuss about this entire advances in the aerospace technology. Like there are many things are there, but because of the time constraint, so I am wrapping it up now. So if you have any specific questions about this aerospace domain and as well as your aeronautical domain, I am happily taking the questions, please. If you have any specific questions, please, I'm happy to answer these questions.
So it was wonderful watching you talking on the advances in aerospace engineering. So we have few questions as I can see in the chat box.
Yes,
Our first question is from Sonali.
yes,
And our first question is, what is the main difference between aeronautical and engineering and aerospace engineering?
yes, ma'am. Very good question. Like aerospace engineering, let me share the screen. Yes, ma'am. Can you see my screen, ma'am?
Yes, yes. So it is visible. I think it is visible to everyone.
Yes. So aeronautical engineering, they will be dealing only with the aircraft, which is flying within the atmosphere. So within the sensible atmosphere, the aircraft which will be flying, that is comes under aeronautical. But aerospace engineering means they will be studying both sensible atmosphere and as well as in space also. They will be dealing with aircraft and as well as they will be dealing with the spacecraft also.
Sonali, I think your doubts are clear. Okay, our second question is, what is the scope for the aerospace engineering students after graduation?
Yes, ma'am. This is also a very good question. Like after graduation, there are many opportunities are there. Like you have to define in which domain you are going, like aerodynamics or propulsion or your design. So accordingly, you have to choose the specific domain, and then you have to dive into this, uh, do some research, and then you will be you will be found you will be getting some opportunity with this startup, and then you are like the way of dimension, and you will be enthusiastic to work with the aerospace people who is interested to develop the mission-based things for ISRO and as well as NASA.
And we have one more question from Ahmed. How can I decide which stream is suitable under the aerospace domain?
Yes, ma'am. And one more nice question. Like while you are studying, you will get to know like while you are studying aerodynamics. So if the aerodynamics is giving good insight in your mind, then go with this aerodynamics. Then when you are designing your fuel and oxidizer and you are doing some propulsion based thing that is admiring a lot, then go with this propulsion domain. Then you are good at designing, and then you are analyzing with this all computational methods, softwares and all. Then go with this CFD based and as well as structural based design, spacecraft design and as well as aircraft design. That will be the ideal way we can go.
Thank you, sir, for sharing your valuable insight and expertise with us. Now, I want to request Rishabh sir, to start your session.
Right. Thank you so much, ma'am. Good
Over to
evening,
you, sir.
everyone present in this session. And I would like to thank Simrit ma'am for such a wonderful introduction of mine. And further, I would like to extend my regards to Dr. Elia for such an insightful presentation and sharing his knowledge. Sir, can you stop sharing your screen?
Yes, ma'am. Yes, yes, sir.
Okay. In the meanwhile, I would like to inform you that today we will be discussing about accreditations, rankings, few of the awards and sports about sports infrastructure, eligibility of the program. So I will not take much of time. I will give you few glimpse of everything. So be with me. Just give me a second. Yeah. Let's
Yes,
start.
sir.
It gives me immense pleasure to inform you all that with 3.684 on 4-point scale, highest
Sorry to interrupt you, Rishabh sir. Am I audible to you?
Yes, ma'am. You are audible.
LPU has been ranked third by Atal ranking of institution. I hope is
Yes,
visible.
yes, sir. Right now you're audible.
Okay, right. I think there was some glitch.
Yeah, glitch.
So
You can start your session now.
Yeah. So as we were talking about the placements, record-breaking package of 3 crore per annum in Germany, 770 plus LP students selected at package of 10, between 10 lakh to 62.72 lakh. Huge achievement. These are few of the glimpses. If we talk about rankings, LPU has been ranked second by World Universities with Real Impact ranking. We have been ranked third by Atal ranking of institution on innovation and achievements. If we talk about sports, LPU creates history. 12 out of 13 LPU students won Olympic medals, gold, silver, bronze. If we move further, LPU won historic National Sports Award, Maulana Abdul Kalam Azad Sports Trophy 2023, first runner-up, awarded by Ministry of Youth Affairs and Sports, Government of India. At 19th Asian Game, our students won medals. Talk about Neeraj Chopra, gold medal in javelin throw, Abhishek, gold medal in archery. List is long. These are few of the glimpses. You can have a look. If we talk about exposure, LPU successfully hosted 106th Indian Science Congress, which was inaugurated by Honorable Prime Minister of India, Shri Narendra Modi. As you can see, the Dalai Lama visited our campus, and Mr. Hamid Karzai, then President of India, Mr. Pranab Mukherjee, and our worthy Chancellor, Sir Dr. Ashok Kumar Mittal Member of Parliament, Rajya Sabha, Shri Arun Jaitley ji, ex-finance minister, Venkaiah Naidu ji, Gohar Gopal Das. Exposure, if we talk about many celebrities also visit LPU campus, MS Dhoni, Sonam Kapoor, Sonu Sood, Ranbir Kapoor. So LPU is also having a Guinness World Book of Record on its name for highest number of people doing Bhangra at single venue. If we talk about world-class infrastructure, an auditorium with capacity of 2,500 plus people, labs, library, uni-mall. You can get all the essential needs from this mall. Gymnasium is there, bowling area is there. We also have 50-bedded hospital as well. Lush green campus, night view of campus. We have Olympic-sized swimming pool as well, shooting range, badminton courts, basketball court, and splash as well. This is the outside picture of the indoor stadium. So let's talk about study ground now. As you all are engineering students, and you might be preparing for JEE Mains and Advanced as well. So we also conduct our own exam, which is LPUNEST, Lovely Professional Universities National Entrance and Scholarship Test. If we talk about this test, this is basically for eligibility. If you want to take admission into BTech program in Lovely Professional University, you need to qualify LPUNEST exam. Apart from this, you can get scholarship also on the basis of this exam. Third benefit of this exam is it gives you study grant as well. If you are among top 500 candidates of LPUNEST BTech and you got yourself admitted into any IIT or NIT by clearing JEE Mains or Advanced, in that case, you will be eligible for one-time 1 lakh rupees study grant to study in IIT or NIT. Only condition is you need to be among top 500 candidates of LPUNEST BTech and you got admission in IIT and or NIT, any of the IIT or NIT. So now let's go live and let's discuss about fee structure, eligibility part. Yeah. So to check all these details, you need to go to www.lpu.in. I'm again repeating, you can note www.lpu.in. Here you just need to click on admission. After that, you need to click here after 12th undergraduate program. There you can select engineering. Under engineering, aerospace engineering. If we talk about BTech aerospace engineering, Duration of this program is 4 years and 8 semesters would be there. If we talk about eligibility of the program, you need to pass 12th class with 60% marks with physics, mathematics, chemistry, and English as subject. Apart from this, you need to qualify LPU Nest exam. Now, let's talk about the fee structure of this particular program. Fees for this program without scholarship is 1,40,000 per semester. But in LPU, fees of a student always depend upon student's own caliber, because LPU give different type of scholarship. You can get scholarship on the basis of LPUness, as we discussed, on the basis of 12th class percentage, as well as on the basis of JE percentile. And there is scholarship for defense personnel as well. And we also have financial aid need-based scholarship as well. We have financial aid for orphans as well. We have financial aid for persons with certain disabilities as well. If we talk about LPUness important dates, LPUness online registration already started from 21st of February. Slot booking for online examination has started from will start from 1st March, that is tomorrow. Last date to apply and book slot for examination is 26th March to 10th of April 2024. Result of LPUness will be announced on 15th of April, and then there will be a round of online counseling. You need to fill your seat preference, as you all are aspirants for aerospace engineering, so you will be marking your preference. Number one will be your aerospace engineering. So for this, you have to do this between 15th April to 17th of April, and result of allotment would be announced on 19th of April. Once you got the allotment letter, you can take admission between 19th April to 25th of April by paying minimum 15,000 rupees. Fees for LPNest program, LPNest is 1,000 rupees for male applicant and 500 rupees for female applicant. And that 15,000 you will be paying at the time of registration would be part of your program fees only. That will be not any extra fees, that will be part of your program fees. So how to apply LPNest? Next question would be in your mind. For that, you can note, you need to go to admission.lpu.in. Once you go to admission.lpu.in, you need to register yourself here with your name, email ID, mobile number. You will need to enter OTP to verify your mobile number, state, city, gender, qualification would be 12th, discipline would be engineering, and you can click here and you will register. And after that, you need it will direct you to your dashboard, and there you need to fill your general detail, make payment, your qualification detail, and then your exam detail, and then you need to book your exam slot. So I hope I have cleared all the important information. If so, over to you, Simrat ma'am. Thank you so much for giving me this opportunity to guide the students. Ma'am, you are mute.
Thank you so much, sir, for your guidance on admissions. So, experts, your year of research, your depth of understanding the topic, and your ability to present the topic in such an interesting way produced one of the most wonderful afternoon for all the attendees. On the behalf of the attendees of this webinar, I would like to thank for all the insightful presentation. Hopefully, the attendees found this webinar to be valuable and will be able to utilize the information provided in this webinar to help to take a better decision regarding your admissions. I'm obliged and once again thankful to Dr. Elia Perumal and Mr. Rishabh for strengthening this platform. Thank you so much.
Thank you, ma'am. Thank you.